All right, 70-1 says identify the domain of the function, vertical asymptotes, and holes of the graph. Now, the domain are everything except what makes your graph undefined. So think of it this way. The domain are a list of all the x values that you can use to plug in. You have to exclude from that list the values that give you undefined. Now, when we have rational functions, we said that if we divide by 0, like 3 over 0, 10 over 0, even 0 over 0, you're going to get undefined. So we need to look for those values that we can't add to our list. And we look for that by just looking at the denominator. So in this instance, for number 1, x over 3x minus 6. Focus on the denominator here. So I'm going to say 3x minus 6. What is going to give me 0? So I say it can't equal 0, because if it equals 0, it's undefined. So x can't equal 2. Now, it's much easier for us to assume everything and just say, well, x can't be this value. So x can't be 2. That's why it's open circle, but it's everything else. And if you're thinking to yourself, well, why is it everything else? Because there's nothing that says that it can't be anything else. Right? There's nothing shown that says it can't be these other things, and so that's why we can assume that. So it'll be from negative infinity to 2, union from 2 to infinity. I'm sorry. Let's go back to that. We didn't finish the problem. So that may be the domain. Now it's asking us to find the vertical asymptotes of the graph, or points of discontinuity. Now for vertical asymptotes, those are the cases where you get a number over 0. Like that number on top is other than. So if I plug in 2 into my function, I get 2 over 0. Okay? That is a vertical asymptote. If you ever get 0 over 0, that's a hole or point of discontinuity. So, because I plugged in 2, I got 2 over 0. I know I have a vertical asymptote at x equals 2. Now, another way to know if it's a vertical asymptote or a point of discontinuity is how it reduces. Meaning, on a side example, let's just say if I had x times x minus 2 over x minus 2. Well, I do have an undefined value at 2, right? Because if I plug in 2, I get 0 in the denominator. But notice how they cancel out. Well, if they cancel out like that, then I know that that's going to be a point of discontinuity or a hole. And so I would say a hole at x equals 2. Now another way of thinking about it is if you plugged in 2, you get 2 times 0 over 0. Well, that's 0 over 0. That's the indeterminate case. That tells us that it's going to be a point of discontinuity. On this next one here, number 2, you get x over x squared plus 1. So I check out the denominator. Now notice, because this is going to be negative, when I take the square root, that's going to give me imaginaries. So therefore, there are no real number that's going to give me undefined. And even think about it, is there any number for x that you can plug in that's going to give you a 0? And there isn't. So there's no vertical asymptotes, and there's no holes. And so the domain would actually be, because there's no undefined values, it'd be from negative infinity to positive infinity. All right, number 4. So factor out the x. This factors into x minus 2, x plus 1. And then that on top should be x plus 1, x plus 1, x minus 2, x plus 1. So now, reducing this, the x plus 1's cancel out. So immediately, I know that at x equals -1, that should be a whole. This other piece here, at 2, that's a vertical asymptote. My domain, I still can't have a -1 or a +2. So for my domain, that is going to be from -infinity to -1 union from -1 to 2 union from 2 to +infinity. But with my vertical asymptotes and holes, right, this is what was left after canceled out. If I plugged in a 2, that would give me a number over 0. That's a vertical asymptote. If I plug in -1, that would give me 0 over 0, which is a hole. So my vertical asymptotes, x equals 2, holes, x equals -1. So for number 7, I'll start you guys off. It gives you I as a 0. Now, because of conjugate zeros theorem, it also says that -I is a 0. So you're going to be plugging in both I and -I. So I and then once you're done with this, whatever you get here, you're going to use -I. Alright, so bring it down, multiply, add, multiply. Now you may have to do that off to the side. So that gives you -2i. I is -1. So that's -2i plus 26. Now multiply. So that's going to give you +2 plus 26i. Add straight down. Now multiply, you're going to get -26, which is 0. So we know it works, but if I is one of the zeros, then you should already know that it works. And so now the other 0, -I, we can use with what's left, bring it down, multiply, add, multiply, add, multiply, add. And so now with this, you're probably going to have to use the quadratic formula because this is remainder constant x squared. And all it's asking you to do is find all the zeros and factor it. So far, one of the zeros, second of the zeros, find the zeros from using the quadratic formula, and then write it as x minus 0, etc. For these, you're going to have to use unit circle. So the secant of pi6, so number 8, well, at pi6, my cosine value is radical 3 over 2. So the secant is the reciprocal, so that's going to be 2 over rad 3, or 2 rad 3 over 3. Number 10, cotangent of negative pi, so -1 pi, -2 pi, -3 pi, -4 pi, -5 pi. So cotangent is going to be cosine over sine. Well, cosine is -1 over sine is 0, so that's undefined.